Dear students, it's my pleasure to communicate with you all through this lecture video. In this video, we will discuss about the CPU scheduling in operating system. CPU scheduling is an important topic in the operating system. Before that, we have to know what is operating system. Operating system is a system software which acts as an intermediate between the user and the hardware. Without the operating system, we cannot work with the computer because the OS is the manager of all the resources. If the user want to work with the computer means the OS should be the one which handles all the terms with the computer. In this, we will see what is CPU scheduling. In this, we will see what is CPU scheduling. Here, we will see if one process allows to execute means the other process has to be in a waiting state. That means the waiting state process have to get some resources for its execution. The aim of the CPU scheduling is to make the system efficient and fast and fair. Next one is there are some key concepts to be keep in mind while working in the CPU scheduling concepts. First one is a single process system. In this, only one process can get the CPU for execution in a given time. Multi-programming. In this, multiple processes are kept in the ready queue so that each and every process gets its turn to get executed by the CPU. And the third one is CPU utilization. In this, the CPU idleness should be minimized and keep the CPU busy all the time with one process or the other. And the next one is process execution. In this, a process should run, otherwise it must be in a waiting state. And the next one is idle CPU. With this, a CPU should be kept idle when it is working in a single processor environment. If it is in a multiple processor environment, the CPU will be busy all the time. And the next one is context switching. Context switching is nothing but the getting the attention of the processor by the process. If the process gets the attention of the processor, it gets executed. Otherwise, it will be in a waiting state so that the CPU switches its attention from one process to another to get the executed. Next one is there are some benefits of using this CPU scheduling. First one is increased efficiency. CPU usage maximizes by ensuring that it has a task to perform even when some processes are waiting for IO operation. Here, the efficiency is increased by maximizing the CPU work, maximizing the CPU usage by reducing the CPU idleness. Next one is the reduced idle time. In order to increase the efficiency, you have to reduce the CPU idle time so that the throughput will be increased. Throughput is nothing but number of instructions executed in a given unit time. And the next one is resource utilization. The resources should be utilized in an improved way so that there should be maintain some balance between the resources allocated to the processes so that we can have an idea of which process is having the which resource at that time. Here we'll see some example. In this example, process 1 starts executing and gets into a waiting state for requesting an IO. That means input output. In the second one, process 2, it gets the attention of the CPU and starts its execution. While P2 is running, process P2 is running, it also requires an IO operation and needs to wait. Here you have to keep it in mind that process P1 is also in a waiting state for requesting a resource or IO operation, and process P2 is also in an waiting state for requesting an IO operation. Now P3, process P3. Now the CPU switches its attention to process P3. Now you'll see that P3 runs the instruction without needing IO. So that it didn't require any IO for its execution. Now P3 completes its execution, but P1 and P2 are until now it is in a waiting state. Once P3 is done, the CPU returns to P1 or P2. Which process having their resource ready, either P1 or P2, it will turns its attention and gets the instructions executed. Here, there is a success mantra between this is CPU scheduling, which is the CPU burst or the IO burst cycle. Here, this cycle is important. That is, in the previous example, we have seen that CPU was switched from process P1, P2, and P3. While P1 gets its execution, P2 and P3 are in the waiting state. Now, the P2 have to enters means the P1 enters into the waiting state. P2 gets the executional phase. Likewise, in that time, the CPU is also enters into the CPU burst and the IO burst. CPU burst means there is computations performing. In the IO burst means the CPU have to wait for getting the process ready. This is an diagram representing the CPU burst and the IO burst. In this, you will see that first the instruction is loaded so that the computations will start it. Next, the process waits for an IO so that it is in a IO burst. Now the CPU burst means the CPU turns the attention towards the same process or the next process, and the next the waiting for the IO. And the third cycle represents the CPU burst, and it again went to the IO. While starting, it is in the CPU burst. While ending, it is also in the CPU burst. There are two types of scheduling. One is preemptive scheduling, and the next one is non-preemptive scheduling. Preemptive scheduling means the higher order jobs, process, or task can request the help of the CPU in midst of the currently running process. This is called the higher priority process have the ability to disturb the CPU. This one is called as the preemptive scheduling. In non-preemptive scheduling, the new process or the newly entered process, either it is a prioritized one or a non-prioritized one, it has to wait until the currently running process has to finish its CPU cycle. Next one is the CPU scheduler. Scheduler is nothing but a manager which is responsible for scheduling the CPU. The function of the CPU scheduler is to allocate the CPU in a short-term basis. That means the processes are kept in a ready queue, means the process have to wait until the CPU gives its service to the process. Whenever the CPU becomes idle, the process have to wait. The scheduler allocates the CPU to the selected process from those in the memory that are ready to execute. Which process is ready means they will get the attention of the CPU and it gets its execution. Here, the ready queue is nothing but a queue which behaves like a queue that we are using in our daily life. Here, there are some terminologies. They may be first in, first out, or priority queue, trees, or unordered linked list like ways. But that you can use any queues like this priority, tree, or unordered or linked list queues. But there is no necessary to follow first in, first out concept. That means the job which the job or process which arrives first will get the CPU is not necessary. It may be in a wait state. Based on the resources it have, we may give the attention of the CPU. All processes in the ready queue are lined up, waiting for its chance to run on the CPU. So that the process have to get a chance to execute with the CPU. Otherwise, the jobs must be kept in a queue. The queue is otherwise called as a pool of processes. And the last one is process control block. Process control block represents the information about each process, such as a process state, program counter, CPU registers, memory management information, and IO state information. Here, there are some criteria to be followed while scheduling the CPU. They are the CPU utilization, throughput, turnaround time, waiting time, and the response time. for optimal performance of the CPU, the above criterias, we will, while we are joining a course, means there some criterias will be followed. No, likewise, while allocating his CPU to the process, means some criterias should be noted. These are the 5 criterias. From that, CPU utilization and throughput should be always high. That means it should be in a maximum way. That means the CPU should be utilized in a maximum way, so that through more number of instructions should be executed in a given unit time. The turnaround time and the waiting time and the response time should be minimized. Turnaround time means the time which is taken into account from the submission of the process to the end of the process. That means the completion of the process is considered as a turnaround time. And the waiting time is before getting the attention of the CPU, the process have to be in a waiting state. After that, waiting state. After that, if the process gets the attention of the CPU and in the midst of the processing, it waits into a searching of IO resources, means it enters into a waiting state. These are considered as a waiting time. And the response time is while the process are kept in a queue, that time is considered as a response time, in which time the CPU is responded to that process. This discussed concepts are displayed here. In this, we will see that the CPU have to be used from 40% to 90%, and turnaround should be always considered as a minimum, should be kept in a minimal way. Waiting time, response time, and turnaround should be kept it in a minimal way, so that the values of this turnaround time, waiting time, and response time should be in a low value. And students, it's very interesting to communicate with you through this video. And we will discuss with the CPU scheduling algorithms in the next video. Thank you.